Hey, welcome back. Up to this point, we've been taking derivatives of functions, and they all have had one thing in common. They've been what we call explicit functions. Now, when I say explicit, I'm not talking about the kind of music you listen to. I'm talking about functions where your dependent variable is by itself. So most of the time you have y equals a function of x, and y is by itself. Today, we're going to look at implicit functions. Implicit functions are one where you can't isolate one of your variables. So your x's and your y's are mashed together and there's nothing you can do about it. And we're going to learn how to take the derivatives of those kinds of functions. I want to teach you how to do this by showing you. So just look at this first example with me. I've got 2y plus x equals x squared minus 1, and I'm asked to find the derivative of this whole equation. So when you go to take the derivative of 2y with respect to x, notice the mismatch there. You're taking the derivative of y with respect to x. You take the derivative just like you normally would. So the derivative of 2y, as you might guess, is 2. But because y is implicitly defined as a function of x, you have to multiply by dy dx. This dy dx is called a differential, and it's part of the process. It's technically part of the chain rule. So the derivative of 2y is 2 dy dx, plus the derivative of x is 1. Now, if you're asking why don't I put a differential here, the answer is you kind of do, because you took the derivative of an x with respect to x. So if I did put a differential, it would be times dx dx. And if your gut tells you that's 1, your gut is right. So I don't write dx dx. That equals the derivative of x squared, which is 2x, minus 0. So if my instructions are to find dy dx, then I want to get dy dx by itself. So I'm going to subtract the 1, divide the 2, dy dx equals 2x minus 1 all over 2. Now, something I want to point out is that this is not technically an implicit function, because I could have gotten y by itself if I wanted to. 2y equals x squared minus x minus 1. So y equals 1/2 x squared minus 1/2 x minus 1/2. And I can take its derivative, dy dx, just the normal way, using the power rule, would be x minus 1/2. And I want to point out these answers are the same. So with implicit derivatives, what's important to remember is if you're taking the derivative with respect to x, which we normally always do, or t, then if you take the derivative of something that's not an x, then you need to tack on that differential piece. That's an application of the chain rule because you've got one variable that's implicitly defined as a function of another variable. So when I look at example 2, y squared equals x to the 4th plus sine y minus 10, I immediately notice I cannot get y by itself. Even if I wanted to, I can't get y by itself. This is an implicit function. So I'm going to take the derivative just like I normally would, but I have to remember to include those dy dx's when I take the derivative of a y. So the derivative of y squared would be 2y dy dx equals the derivative of x to the 4th, 4x cubed, plus cosine y dy dx minus 0. And so I want to get dy dx by itself. So what I'm going to do is I'm going to take all my dy dx's and send them to the same side of the equation. So I've got 2y dy dx minus cosine y dy dx equals 4x cubed. Now when I look at the left side of my equation, I notice that all of these terms have a dy dx in common. So I'm going to factor that out, giving me on the left dy dx times 2y minus cosine y equals 4x cubed. And then finally, I can divide everything else from the left-hand side to get dy dx by itself. So dy dx equals 4x cubed divided by 2y minus cosine y. And for a lot of people, the fact that I have a y in my final answer might be a little bit uncomfortable, but oftentimes it's unavoidable because this is an implicit function, not an explicit one. So just a quick tip, if you go back and look at the last two problems we did, you'll notice they kind of follow the same script. Every implicit differentiation problem is going to follow the same four-step process. You're going to take the derivative of both sides of your equation. Don't forget your dy dx's. You're going to collect all your dy dx's on the same side and put everything else on the other side. Factor out the dy dx and divide. So if you go back and look at the example that we just did, I took the derivative, I collected all the dy dx's on the same side, I factored out dy dx, and divided. And so if you know that every problem is going to follow this same 4-step process, it's really not that bad. All right, so we're going to practice a couple more of these implicit derivatives. Looking at this one, find dy dx, 2y plus 1 equals x times y. So when I go to take my derivative implicitly, the derivative of 2y is going to be 2 dy dx equals, now look out here, when I go to take the derivative of x times y, I need the product rule. So the derivative of x, 1 times y, is y, plus x times the derivative of y, which would be 1 dy dx. So I take my implicit derivative, collect all my dy dx's to the same side, factor out, and divide. So 2 dy dx minus x dy dx equals y, factor out, and divide. And something I want to point out, once you do some of these problems, you'll notice that you can probably skip some of these steps. For example, from here, it's not uncommon to jump straight to here. And if you can do that correctly, there's nothing wrong with that. Okay, I want to show all the steps just for the sake of teaching this to you, but don't feel like you have to write every step if you are capable of jumping from one to the next. Example 4 says, find dy dt. So take the derivative of y with respect to t. So what that means is anytime I take the derivative of a variable that's not a t, I need to tack on that differential piece. And when I look at this, just planning ahead, I see this 2t cubed y squared. I know I'm going to need the product rule for that. So let's tread carefully here. So here we go. The derivative of 2t cubed y squared, using the product rule, the derivative of 2t cubed is 6t squared times y squared plus 2t cubed times the derivative of y squared, which is 2y dy dt. Okay, there's that differential piece. I took the derivative of a y with respect to t, so I tack on the dy dt, minus 4y cubed dy dt equals, the derivative of 4t is just 4, minus the derivative of y is 1 dy dt. So after taking a step to clean this up just a little bit, I can start collecting all my dy dt's on one side and sending everything else to the other side. So I'm going to have 4t cubed y times dy dt minus 4y cubed dy dt plus dy dt equals 4 minus 6t squared y squared. And here you can take a look and hopefully notice what I was talking about just a moment ago. I know the next two steps are factor out dy dt and divide. So my final answer is going to have a numerator of 4 minus 6t squared y squared and a denominator of 4t cubed y minus 4y cubed plus 1. So if you understand that and you're comfortable making that jump, feel free to do so. Example 5, find the slope of the line tangent to the curve. Okay, so find the derivative of x over y minus 2 equals y squared at the point 3, 1. So they want me to take a derivative and then plug in 3, 1. And when I look at this, I immediately recognize I'm going to have to use the quotient rule to take the derivative of x over y. So here we go, starting off with the quotient rule. The derivative of x is 1 times y minus x times the derivative of y dy dx divided by y squared equals 2y dy dx. Okay. Just one quick note, the most common mistake that I see students make on implicit derivatives is you get so caught up in your head trying to remember all your derivative rules and trying to remember your dy dx's that sometimes a constant can sneak its way into your derivative. I see a lot of students put a minus 2 in their derivative, not remembering that the derivative of minus 2 is 0. And on the AP exam, you can bet if you make that mistake on a multiple choice problem, that answer will be there waiting for you. So be careful with those constants. So now that I'm here, I have an interesting choice to make. I can simplify. I can try and get dy dx by itself, then plug in 3, 1. Or since I've taken the derivative, I could just plug in 3, 1 now and then try to get dy dx by itself. Both will work. Really, it's up to you to look at a problem and decide what looks like it would probably be easier. I think for me, now that I've taken the derivative, I would rather just plug in now. So when I plug in 3, 1, I get 1 minus 3 dy dx divided by 1 squared equals 2 times 1 times dy dx. And after plugging in, the process of getting dy dx by itself is now much simpler. On the left, I've got 1 minus 3 dy dx equals 2 dy dx. And as you're solving this, just treat dy dx like any other variable. So I've got minus 3 of them on the left I want to add over to the right. So 1 equals 5 dy dx's. And then divide by 5. So dy dx at this point is 1/5. And to finish off today, 2008 BC number 19, what's the slope of the line tangent to the curve? Okay, what's the derivative of y plus 2 equals x squared over 2 minus 2 sine y at the point 2, 0. One thing I want to point out before we get started, don't be tricked into thinking that you need to use the quotient rule right here, x squared over 2. I'm just going to rewrite x squared over 2 as 1/2 x squared. They're the same thing, but now you can easily see that that's a power rule derivative, not a quotient rule. So I need to take the derivative of this implicitly and then plug in 2, 0. So the derivative of y plus 2 is dy dx equals the derivative of 1/2 x squared is going to be x minus the derivative of 2 sine y would be 2 cosine y dy dx. And again, we can simplify this, get dy dx by itself first, or we can just plug in 2, 0. I'm kind of partial to just plugging in 2, 0. So dy dx equals 2 minus 2 cosine of 0 times dy dx. That gives me 2 minus 2 times 1, so 2 minus 2 dy dx. Add 2 dy dx's over to the left-hand side, so I've got 3 dy dx equals 2, and divide by 3. So dy dx at this point is 2/3, and my answer is D. So to wrap up here, when you see an equation where y's and x's are mashed up together and you can't get y by itself, you're going to take the derivative implicitly, which means take the derivative of the entire equation using all the derivative rules that you already know. But when you take the derivative of a y, you have to tack on that differential piece. If you're taking the derivative of a y with respect to x, then you need to multiply your derivative by dy dx. Okay? Then follow the 4-step process that we talked about. Take your derivative, get all your dy dx's on the same side, factor out dy dx, and divide to get your derivative. Or if you're plugging in, if you just want to know the derivative at a point, sometimes you can skip all the simplifying, take the derivative, plug in your point, and then solve for dy dx that way. In the next video, we're going to get some more practice with implicit derivatives because we really need to be good at these before we tackle related rates 2 topics from now. So I hope that helps. Thanks for watching.